Hi, welcome to the continuation of our instructional design framework, and I am your presenter for today, Jennifer M. Ostar. Let us first have our learning objectives. By the end of the presentation, the audience will be able to define the concept of instructional design and explain its importance in education. Identify and describe the 6 major instructional design frameworks, such as the ADDIE, Assure, SAM, CAMP, Gagne's 9 events, and Merrill's first principles. Differentiate among these frameworks based on their focus, process, and application. Illustrate examples of how each model can be applied in classroom or e-learning settings. Evaluate which model is most appropriate for specific instructional contexts, and integrate the principles of these models into own lesson or curriculum design. Let's have the overview of instructional design framework. Instructional design is a systematic process of designing, developing, and delivering learning experiences based on principles of learning and instruction. Why we have to make instructional design framework before we have our teaching and learning process? It makes teaching more effective and efficient. It aligns learning objectives, activities, and assessment. And it addresses the learner's needs through structured design. Since this is structured, it follows a certain step or a certain pattern in how teaching and learning could progress. In other words, it serves as the blueprint for instructional planning, and it makes learner engagement and learner outcomes more manageable. And of course, it encourages evidence-based teaching practices by ensuring alignment between content, objectives, and assessment. So here, we tend to plan what would be the content of our lesson, then we develop the objectives and set different activities for us to reach the objectives, and then we assessed if the learners had understand the lesson through giving of evaluation as part of the steps in this model. So here, I will be giving you the overview of the major instructional design models. We have a lot, but we will enumerate only the major 6. We have here the ADDIE, the Assure, the SAM, the CAMP, the Gagne, and the Merrill. The ADDIE's focus is on systematic design. It is linear and best used for curriculum development. Assure is focusing on media and technology integration. It is also linear and is best used for technology-enhanced lesson. We have SAM. It's for rapid prototyping. It is iterative. It is used for e-learning designs. Then we have CAMP. It is holistic learner focused and is flexible as well as best in curriculum mapping. We have also Gagne. It is on learning sequence. It's stepwise and best used for lesson planning. Then we have the last among the 6, the Merrill. It is for real-world learning and it's problem-based. It's best for performance tasks. Now, let's tackle the ADDIE model as the beginning of our instructional design framework. To begin with, ADDIE stands for analysis. In this phase, you need to identify the following: the course learning outcomes, the learner characteristics, the learning gaps, required resources, ideal desired learning environment. In this phase, you will identify the module-level learning objectives. It identifies the assessments and activities, as well as it designs the learning environment. So here, it is the design phase. We develop the blueprint and the syllabus, or the plan itself. The letter D stands for development. In this phase, you will construct and refine content based on the guidelines. We develop assessment and activities and finalize learning materials. And for the 4th step, the implementation, in this phase, you will pilot the developed course, ensure all functions of the system is running. You do minor modification if it needed. The last, the 5th step is the evaluation. In this phase, you will conduct formative and summative evaluations for further improvement. So the end goal is to find loopholes in the process, and through feedback, we will be giving what needs to be improved. That's why it's called evaluation. We do the assessment. So once again, here's the cycle of the framework. A is for analysis, D is for design, D is for development, I is for implementation, and E is for evaluation. It is a systematic instructional design framework because it follows a certain process, as you remembered from our discussion. It was developed by the Center for Educational Technology at Florida State University in 1970s for the U.S. Army training programs. And that is used to effectively and efficiently engage our people or our educators through continuous evaluation and improvement. So that's to improve. The plan is been developed first to improve a certain process or even a developed material. And now, each process follows a certain phase. For analysis, we focus on the needs. For design, we strategized. For development, the keyword is to create. And for the implementation, it's the delivery of the instruction. And for the last step, that is the evaluation. You assess whether the developed material based on the needs of the learners is being achieved. Is it effective or not? And if it is found not effective, then revisions are made based on the suggestions. Here are the 5 examples and outputs where the ADDIE model is applied in teaching and learning scenario. The first one, following the analysis phase, teachers can identify performance gaps, define instructional goals and objectives, analyze learner demographics and context, and determine available resources. What is the best scenario? A teacher reviews reading assessment data and identifies that grade 4 students struggle with comprehension. Then the problem is being found out. For the output, it could be a needs assessment report or learning objectives draft. Then, after the need has been identified, we design. That's the second step. We create a blueprint of the learning experience. It could be done through the following activities. Write measurable learning objectives, select instructional strategies. Is it a group work, a problem-based learning? Then we plan assessments. Is it through quizzes, performance tasks, and the like? Or we also design lesson flow and materials. Classroom scenario is when a teacher designs a module that uses interactive reading journals and formative quizzes. The output would be lesson plan, storyboard, and assessment plan. For the third step, after we design, we develop. It is the creation and production of learning materials and activities based on the design plan. We develop the content through PowerPoint, videos, worksheets. Then we integrate technology tools such as the LMS, the interactive media. Then we conduct pilot testing for quality assurance. Examples in classroom is creating multimedia presentations and worksheets for blended science class. And for the output, instructional materials ready for classroom delivery. Let's head to the fourth step, the implementation phase. It is the actual delivery of instruction or training to learners. We can orient learners and instructors. We manage learning environment and logistics. We deliver lessons or deploy e-learning course. Then we provide support during instruction. Example in classes when a teacher facilitates hybrid classes using Google Classroom and in-person discussions. For the output, we have teaching delivery, learning engagement, and reports. And now let's head to the evaluation, the last phase of the ADDIE model. We tend to measure the effectiveness and efficiency of instruction and making improvements. Key activities would include the formative and the summative evaluation. We conduct the following throughout the ADDIE phases for ongoing improvement, or it could be done after the implementation to measure learning outcomes. Best example is when teachers collect student feedback, analyze test scores, and revise the module based on the result of the assessment or the evaluation. Then the output is evaluation reports and recommendations. And the practical application in education could be summed up in the table that I already prepared. ADDIE model can be used in curriculum development. Example is when designing the Matatag curriculum framework. Then it is also applicable for teacher training on training differentiated instruction. Then it is also used for lesson planning, just like designing the daily lesson logs or the DLLs of teachers. Then it is also applicable in e-learning, or in the Depth Ed Learning Management System courses, or the LMS in Depth Ed is the best example for this. So they are applying the ADDIE model. Again, what is ADDIE? A stands for analysis, D for design, D for development, I for implementation, and E for evaluation. So I also presented some scenario wherein ADDIE model is applied in the teaching and learning process. Example, a senior high school teacher wants to improve students' oral communication skills. Under analysis, the teacher conducts needs assessment, wherein the weak part or the needs of the teacher or the learner is being presented. Under design, the teacher plans communicative activities. It is through lesson plan and objectives. Then we have the third phase, development, creation of rubrics and materials, and we could expect an oral performance test. Then for the implementation, facilitate speaking workshops. It's for the learner participation and outputs, and the last is evaluation or the collection of feedback and scores. Then we can revise a strategy for improving students' oral communication based on the result of the feedback and the scores gathered from the learners. After we have the different examples on how the ADDIE could be applied in school, here are the strengths and limitations of the framework. For the strength first, it is systematic and organized. Of course, it promotes continuous improvement. It is learner-centered and data-driven. It is flexible for traditional and digital learning. And for the limitations, it can be time-consuming since it follows a certain step. It requires technical skills for development, and it is linear approach and may not fit to all learning contexts. And as our key takeaways for the first model, the ADDIE model, it emphasizes analysis, design, development, implementation, and evaluation as iterative processes. And in education, it ensures instructional alignment, effectiveness, and learner engagement. And the ADDIE model is considered a foundational in instructional design. Let's now head to the second framework, the Assure Instructional Design Model. First, let's have the overview. The Assure model starts with the A, analyze learners. It is followed by the S, state objectives, followed by another S, select methods, media, and materials. U, utilize media and materials. R, require learner participation. And E, evaluate and revise. As you can see from the discussion earlier, we could say that the Assure model is somewhat the same as the process of the ADDIE model. But the difference is, we also value the phase wherein there's the learner's participation. In ADDIE model, we also look for the needs. Then we end up with the evaluation or the giving of feedback. But what is with the Assure model, we also value participation. So let's see how it is a bit different. It is also an instructional design framework that helps teachers plan and deliver lessons that integrate technology and media. As we can see here, we use Assure model if the focus is on technology integration. It is developed by Hainish, Molenda, Russell, and Smaldino, 1996. The purpose is to provide systematic approach to lesson planning, ensure learner-centered and technology-enhanced. It promotes effective use of multimedia tools, and aligns learning objectives with instructional methods and assessment. The same as ADDIE, we follow certain steps. Step 1, analyze the learners. We need to understand learners' characteristics to tailor instruction. Here are the factors to consider when we analyze learners. Of course, we have to know the age, the grade level, the cultural background. Then we have the prior knowledge and skills, as well as the styles on how learners would understand lessons, such as visual, auditory, kinesthetic preferences as their learning styles. And of course, we must consider different competencies. One best example for this phase is the teaching of photosynthesis. We assess students' prior understanding of plant biology through a short quiz. That's one of the best. Step 4, the Assure model. Step 1, analyze learnings. Now we proceed with step 2, state objectives. Design or define what learners would achieve after instruction. We can use the ABC method in developing objectives. We ask ourselves, who are the learners? It stands for the A as the audience. What should they do? It's the B for behavior. Under what conditions? It's C for condition. And to what level of accuracy or degree? For you to better understand how to develop the ABC method, here's the sample. By the end of the lesson, the students will identify the stages of water cycle using a diagram with 90% accuracy. As you can see here, the ABC method is being applied. A as the audience, B as the behavior, C as the condition, and D as the degree. It mentions the learners, what they need to do, what are the conditions that they need to apply, and the level of accuracy. So this is the percentage. Now, let's head to step 3, or selecting of methods, medias, and materials. Choose the most effective tools and strategies for learning. We can have this process. Decide on the teaching method. Is it a form of lecture, discussion, simulation, or others? We select media types. Is it a video, a presentation, an online quiz? And then we prepare instructional materials. Is it in the form of handouts, slides, or visuals? So those are the factors to consider when we prepare the methods, the media, and the materials to be used in the teaching and learning process. Then here's the best example. The teacher might decide to use the PowerPoint slides, an interactive water cycle simulation, and a group discussion activity. Then for step 4, utilize media and materials. Choose the chosen materials effectively in class. Then we consider the following in utilizing media and materials. The 5 P's for implementation. First, preview the material, followed by prepare the environment, prepare the learners, present the materials, and provide learning experience as the 5 P's of implementation. How can we show this in class? First, test the projector before showing a video. Brief students about the activity before it starts. So it follows the preview, prepare, present, and provide as the 5 P's for implementation. Then we have the step 5, requiring learner participation. So this one is unique with the Assure model. As you can revisit the ADDIE, there's no step requiring participation. After the implementation, there's the evaluation already. But here, we have step 5. Engage learners actively in the learning process. It could be through discussion, collaboration, and hands-on practice, or the use of interactive technologies like quizzes, polls, or virtual labs. Students work in pairs to create an infographic explaining the water cycle using Canva or Google Slides. As you can see, here's working in pair, wherein learners can explain what they had been preparing or doing as part of activities. Then the last step, evaluate and revise, almost the same with the ADDIE model. Here, we assess learning outcomes and instructional effectiveness. We can use the learner evaluation and instructional evaluation. We measure achievement through tests or performance tasks, and we reflect on teaching strategies, materials, and delivery. So we look on results and even the status of the materials being developed. It could be done by administering a post-lesson quiz and gathering students' feedback to improve future lessons. The same as the step in the ADDIE model. Here's a practical application of our Assure model. It can also be used for lesson planning, technology integration, teacher training, e-learning. So specifically, Assure model is used in integrating multimedia in our lesson, and this is one best used through science classes. As you can see, there are lots of processes in science wherein different ways on how to show science activities can be done. So if we integrate technology. Then now let's have the benefits and limitations of the model. First, the benefits of Azure model is to promote active and engaged learning, integrates technology systematically, ensures alignment between objectives, teaching and assessments, and encourages reflection and continuous improvement, having the process from the letter A up to letter E. And for the limitation, same as the ADDIE, it is time-consuming to prepare and requires access to technology and resources since this is technology-driven. So if you are planning to develop a lesson with the use of technology, Azure model is one of the best material or best design to apply. For our key takeaways, before we proceed with the next, Azure model guides teachers to design learner-centered technology-rich lessons. Each step ensures planning, implementation, and evaluations are connected. So the content, the activities, and even the evaluation or the assessment would be part of the process and making it more aligned. Then it's practical for both traditional and digital classrooms. Now we're done with the Azure model. We will now proceed with the third, the successive approximation model. Here's a sample diagram of the process. We have three phases: the preparation phase, the iterative phase or iterative design phase, followed by iterative or iterative development phase. So from the preparation, we gather information, the same as the two previous models. Then we have the SABI start, project planning, additional design. Then we have design proved. We have alpha, beta, and the gold. Then at last, it's the rollout. Let's continue. Once again, I'll mention about the three phases: preparation phase, iterative design phase, followed by iterative development phase, which we will further elaborate on the succeeding slides. We have here the definition. The successive approximation model is iterative agile approach to instructional design that emphasizes rapid design, prototype creation, and continuous feedback. It is developed by Dr. Michael Allen in 2012. He's the founder of Allen Interactions as an alternative to the rigid ADDIE model. And the purpose is to produce effective learning experiences quickly, allowing for flexibility, collaboration, and ongoing improvement. Let's compare ADDIE versus SUM, since the ADDIE had been presented earlier and it's mentioning that the SUM is an additional improvement of the ADDIE or alternative of the ADDIE model. SUM focuses on successive improvements. Each version or prototype gets better through continuous testing. So that's a difference. Let's compare when it comes to approach, development, feedback, focus, and speed. ADDIE is linear and systematic, while SUM is iterative and cyclical. For the development, ADDIE is step-by-step, then SUM is prototype-driven. For the feedback is given at the end of the phase under ADDIE, but in some model, it is continuous and early. As to focus, ADDIE is on formal documentation, while SUM is rapid in collaboration. And for the speed, it is slower and structured in ADDIE model, while it's faster and flexible in the SUM model. So we will further elaborate such in this illustration. Two main versions of the SUM. First, let's define the basic model. It's a simple three-phase process for small projects. We start with this illustration. Okay, as you can see, the simple one, there's the concept of evaluate, we design, we develop. It's a cyclical, so we do not know which will come first, which will end last. Because from time to time, we are asking for the feedback. There's an immediate correction. And for the Sum 2 or the extended model, a detailed version designed for large-scale projects or organizational trainings. As I mentioned earlier, we have preparation phase, iterative design phase, and the iterative development phase. But the same as the previous model, there's always the needs analysis or looking for the background or the information to be gathered. And there's the design, the review, the development, the implementation, and the evaluate. The same as the ADI, but this one is more of the cyclical process because every time that they develop something, there's always feedback at hand. Unlike the ADI, the feedback is given at the end. So in other words, this is most of trial and error. If there's a feedback at the middle, then revisions are already or at hand. So for the preparation phase, we gather information and learners' needs, we define learning goals, and we conduct preliminary analysis. For the iterative design phase, we brainstorm and sketch prototypes, we create simple versions of lessons or activities, then review and refine through feedback. This is the one that I'm mentioning. It is already giving feedback, even at the middle. Then for the last, iterative development phase, we build, test, and modify learning materials. We pilot lessons with learners and produce final version after several iterations. Or if we have found out that there are suggestions, feedbacks, and more, we kept on improving or developing something based on the ones being given. For Sum 2, the process is expanded into 9 distinct steps. We have the SAB Start, a collaborative brainstorming session where designers, teachers, and stakeholders will create early ideas. Then it's a preparation, we gather information. SAB Start is a kick-off meeting or the consultation. For iterative design, we design prototype, we review, we revise. It's a loop because when you say iterative, it's a cycle. Then iterative development, we develop, we implement, we evaluate, then we go back to the loop again. We tend to review, revise based on the different feedback given to us. Then, for you to better understand the model, I have here scenario. A teacher develops an e-learning module for grade 10. Let's apply the phases. For the preparation, we collect data on students' needs. Sample output to be lesson goals are being identified. Under design, we create prototype slides and activities. And yes, there's an early version of the module since we do the designing already or the creation. Then for the development, it is tested with students and revises based on the output or the feedback. And yes, it's the improvement or there's a revision based on the result of the test and the feedback given by those who use the material. Some practical applications in education. Curriculum and lesson design, teacher training programs, e-learning and digital modules, and instructional material development. So the same as the first two instructional design framework, these are also used in the following scenarios. So what's the good side? Teacher can prototype and test lessons with students before fully roll out. It allows trainers to adjust modules based on participants' response. It is ideal for developing online courses or LMS content that evolves through feedback. And it encourages creative collaboration among teachers, learners, and administrators. So this is more proactive since most of the time, most of the cycle, refinement is done based on feedback. The output never stops as long as feedback is always supported or always be given. So at the end, we can say that teachers will be able to produce a better result since most of the time, feedback and refinement is applied in this model. For the benefits and limitation of SAM. Benefits: faster design and delivery, encourages teamwork and collaboration, incorporates early and continuous feedback, adapts easily to learners' needs, promotes creativity and flexibility. For the limitations, requires active participation and time from stakeholders, may cause confusion with clear project goals. difficult to apply in rigid institutional settings, needs iterative mindset and technological support since it requires the feedback and improvement from time to time. So I could also say that this one is also time consuming. But then it is also promoting best results since correction is already incorporated from or all throughout the process. Let's now have the comparison between SUM and ADDIE in classroom practice. When it comes to feature, we have here lesson planning. In ADDIE, it is fully designed before teaching, while in SUM, the pilot and refine the lesson weekly. So there's always an interaction or feedback. For assessment design, in ADDIE, assessments finalized before the class. In SUM, ongoing feedback used to modify assessments. And e-learning. For ADDIE, it requires long development timeline, while in SUM, it is rapid prototyping and updates based on the learner's data. So immediate feedback is being processed in the SUM, while ADDIE is at the end of the evaluation cycle. Continue. For our key takeaways in SUM, it emphasizes iteration, collaboration, and agility. It's a modern approach suited for today's dynamic educational environments, and it promotes continuous improvement and learner engagement. Instructional design framework, the Kent model. It also follows a certain step and in sequence. And for us to better understand the model, here's the definition, the component, and the purpose. It is a learner-centered instructional design framework that emphasizes continuous planning, design, development, and evaluation. The proponent is Gerald E. Kent in 1977. Its purpose is to provide a flexible, cyclical, and non-sequential model allowing designers to start at any point in the process. So unlike the previous models, which starts with a definite process or step, it could start at any point. Let's see how it works. For the purpose and importance, it provides a comprehensive approach that addresses all aspects of instruction. It focuses on learner needs, instructional objectives, and evaluation. It encourages ongoing revision and adaptability throughout the process. The 9 elements of the Kent model is shown in our illustration. First, identify instructional problems and specify goals. Examine learner characteristics. Identify subject content and analyze task components, followed by statement of instructional objectives for learners, then sequence content logically, followed by design of instructional strategies to achieve objectives, planning instructional delivery or the method, the media, and activities. Then, develop evaluation instruments to assess objectives and select resources and support services. As you can see on the diagram, we have here a highlight of analyze, implement, design, and develop. And at the center of the model is the evaluate. The same as the previous models, there's always identification of the problem, then statement of objectives, designing and planning of the material or the delivery, and then there's always the evaluation part. Let's dig deeper into the Kent steps with corresponding examples. For step 1, we have identification of instructional problems and goals. Here, it determines what learners must learn and why. Example, teachers identify poor performance in reading comprehension and aim to improve understanding through targeted instruction. Step 2, examine learner characteristics. Analyze learner demographics, prior knowledge, motivation, and learning preferences. A teacher surveys students to understand their reading habits and preferred learning style. Are they visual, auditory, and the like? The same as what we had in our previous modules, right? Then we have step 3, identifying subject content and task analysis. Here, we break down the topic into smaller, teachable components. For example, a science lesson on ecosystems identifies subtopics like food chains, energy flow, and adaptation. So here we tend to look for the subject content and the task analysis, wherein we divide this into subtopics. The keyword is breaking down into smaller teachable components. For step 4, state instructional objectives. We specify what learners will achieve at the end of the instruction. Students will be able to describe the flow of energy in an ecosystem using a diagram, as an example. Then we have step 5, sequence content. We organize topics in a logical order to build understanding progressively. Then we begin with individual organisms, samples, food chains, food webs, and energy pyramid. Then step 6, design instructional strategies. Here we determine teaching methods and activities that promote learning. We use group projects, videos, and simulations to explain ecological system. So now, after we do the instructional planning, we do the delivery, or we plan instructional delivery as step 7. We select suitable media, resources, and activities for instruction. We use PowerPoint slides, printed handouts, and interactive software for a blended learning approach, as an example. Then step 8, develop evaluation instruments. We assess whether learning objectives are achieved. Example, create quizzes, performance rubrics, and reflection activities to evaluate comprehension. And the last step in the CAMP model is to select resources and support services. Here, we identify logistical and technical resources for lesson implementation. Example is the securing of computers, projectors, science kits, and teacher aids for the learning activity. Here are the benefits and limitations of the CAMP model. For the strengths, it's flexible and continuous, since it is mentioned that it could start at any point. Then it is learner-centered and adaptable based on the needs of the learners as well. It encourages ongoing evaluation and improvement. And for the limitations, it can be time-consuming as well and requires detailed data collection. For our key takeaways, the CAMP model is holistic and flexible, focusing on learners and outcomes. Its cyclical nature allows educators to improve instruction continuously and best suited for complex and technology-supported learning environments. Now, let's have the Gagne's 9 events of instruction. Are you excited? It's developed by Dr. Robert Gagne, a pioneer in educational psychology in 1965. It is also a systematic instructional design model that outlines 9 key teaching steps to promote effective learning. This aligns teaching strategies with how the human brain processes information. First, of the 9 events of instruction, Step 1, gain attention. Step 2, inform learners of objectives. Step 3, stimulate recall of prior learning. Step 4, present the content. Step 5, provide learning guidance. Step 6, elicit performance or practice. Step 7, provide feedback. Step 8, assess performance. Step 9, enhance retention and transfer. The 9 events of instruction is further elaborated with the following steps, goals, examples, and in practice. Step 1, gain attention. Here, we arouse curiosity and focus learners' minds. Example, show a short science demo before explaining a concept. In practice, it uses a thought-provoking question, short video, or surprising fact. We can start a lesson with a real-world problem or a visual to gain the attention of our learners. Then for step 2, inform learners of objectives. Let learners know what they will achieve. By the end of this lesson, you will be able to explain the water cycle as an example. Post objectives at the start of each class. Align lesson activities and assessments with these goals as an application of the practice. Then for step 3, stimulate recall or prior learning. It connects new knowledge to what learners already know. Ask review questions or recall a previous lesson. Use brainstorming or quick quizzes before introducing a new content. Step 4, present the content. Deliver new information clearly and engagingly. Example, use visuals, discussions, multimedia, or demonstrations. In practice, integrate technology examples and real-life applications. Avoid information overload, focus on clarity and organization. Let's now proceed to step 5, provide learning guidance. Support learners with cues and strategies for understanding. Example, provide step-by-step instructions, mnemonics or guided notes. In practice, scaffold tasks with examples and analogies. Encourage active note-taking or guided practice. Step 6, elicit performance or the practice. Allow learners to apply what they learned. Example, problem-solving activities, role plays, or simulations. In practice, students practice solving math problems after a demonstration. Encourage immediate application for reinforcement. Let's proceed to step 7, provide feedback. Give timely and specific information about the performance. Correct errors, confirm correct responses, and explain solutions. And in practice, use rubric peer review or teacher comments. Promote constructive improvement. Let's proceed to step 8, assess performance. Evaluate if learning outcomes were achieved. We can conduct quizzes, test or performance tests, and we can align assessments with learning objectives. Include both formative and summative assessments. And the last step is the enhanced retention and transfer. It helps learners apply knowledge in new contexts. Example is to assign projects or real-life problem-solving tasks, and in practice, use group work, reflection, or cross-subject integration. Provide review materials and follow-up activities. As you can see, we can say that the Ganya's episodes or steps of learning as an instructional design framework is the one closest to our lesson planning in the Department of Education. As you are familiarized with DepEd Order number 42 series of 2016, so we have there 10 steps or 10 subheadings in the way we do our lesson plan. And as you can observe, it is mostly related to Ganya's modular episodes of learning. Now, let's proceed with the benefits of the model. It promotes structured, effective teaching. It supports varied learning styles. It enhances learner motivation and engagement. It aligns objectives, activities, and assessments just like other models. And it is adaptable to classroom, online, or corporate training. And our key takeaways for this model: Ganya's model links cognitive processes with instructional design. Each event plays a critical role in effective learning delivery and practical for both traditional and digital classrooms as well. Now let's proceed with the last model for this session, the Merrill's first principle of instruction. As you can see from the diagram, it is task-centered. The keywords involved here would be activation, demonstration, application, and integration. As defined, it is a set of fundamental evidence-based principles that promote effective, efficient, and engaging learning. It is proposed by Merrill, or Dr. M. David Merrill, in 2022. It is considered as Merrill's first principles of instruction. According to Dr. Merrill, learning is promoted when learners are engaged in solving real-world problems and when instruction follows 5 core principles. That's why the last part is integration. Let's analyze the 5 first principles of instruction according to Merrill. First, problem-centered. Learning is promoted when learners engage in real-world problems. Second, activation. Learning builds on prior knowledge and experience. Third, demonstration. New knowledge is demonstrated to the learner. The fourth is application. Learners apply new knowledge and receive feedback. And the last, integration. Learners reflect on and integrate new knowledge into their life. So this is also incorporated in our revised K-10 curriculum in DepEd, wherein most of the activities or lessons were problem-centered and leading to the integration. It's not just the application of what they have learned, but you reflect on the new knowledge to real-life scenario, as you can see on our diagram. Now, let's analyze the principles one by one. Principle 1, problem-centered. So this begin learning with real-world tasks or problems. Example, in a math lesson, students solve a budgeting problem for a school event. Application, you can use case studies or scenarios and let students discover solutions collaboratively. Principle 2, activation. Connect new information with learners' prior knowledge. Example, before teaching photosynthesis, ask students to recall what plants need to grow. Then for application, conduct brainstorming sessions. Use the KWL charts, the know, want to know, and learn. For principle 3 or the demonstration, show learners what to do and how to do it. Teacher model solving a math equation step by step. And for application, use visuals, videos, or live demonstrations. Encourage observation and guided notes. Let's proceed to principle 4, application. Let learners practice and apply their new skills. For the students, they practice editing paragraphs after a lesson of grammar as one of the application. The learners were able to do something out of what they have learned. Example, provide exercises and simulations, give immediate constructive feedback. And for the fifth principle, the integration. It's the highest form, wherein we encourage learners to use and reflect on what they've learned. Example, students create a short video demonstrating what they learned about environmental protection. That's why we assign projects, reflections, or peer teaching. We encourage sharing of insights and experiences as part of what they have learned. So now, let's have the summary of the 5 principles. So here, problem-centered, of course, the focus is key-world tasks or real-world tasks. Example activity, budget planning. For activation, the focus is prior knowledge. We have the KWL chart as an example. For the demonstration, we do the modeling. We video or live demonstrate a lesson or a topic. For the application, we practice. It could be in the form of group exercises. And for integration, the keyword is reflection. It would be a student presentation wherein they integrate or reflect what they have learned. And now let's lead to the strengths and limitations of this model. For the strengths, it promotes active, meaningful learning. It encourages problem solving and critical thinking. It focuses on learner engagement and real-world application. Applicable to both classroom and online setting or learning. And for the limitation, it requires careful planning and realistic scenarios. It's time-consuming to implement fully. As what we have discussed earlier, so most of this one are time-consuming, requires planning. But this one, what's very specific with this model, it's focusing on the real-life scenario, and there's always the integration at the end. Key takeaways for this model: Merrill's first principles ensure deep learning through engagement, practice, and reflection. The model supports both traditional and digital education, and it is effective instruction that connects theory with practice to solve real-world problems. So my question to everyone: how do you apply instructional design framework in the workplace? What are the things to consider in preparing your instruction? Out of the 5 or 6 models that we have discussed today, which do you think is mostly used? And how do you think it is being applied in your school scenario? And to end my presentation, here are the references that I have used to gather the information and data for each topic. Once again, thank you so much. I am Jennifer MOS Star, delivering you the topic on instructional design framework.